All right, hi everybody. Welcome to the Clew Summer Research Demo Day. My name is Paul Ruvalo. I'm the head of the Olin College Crowdsourcing and Machine Learning Laboratory over here in Boston, Massachusetts. Also introducing the program will be Fernando Albertorio. I'll turn it over to him in just a little bit. We're really excited to have you all here today. This summer, the students, the research team has been doing some really great work, but it's really been a collaborative effort among the research team, but also the larger community, especially our co-designers who have been working with us over the last 4 weeks or so. Clew is an application that has been designed for people who are blind or visually impaired to navigate. The focus is navigation within indoor environments. And we found that the key to making this technology work for folks is to work closely with the community to get great ideas and get feedback. And that's certainly been the case this summer. And we thank everybody who's participated in that as part of the team in that respect. So I'm just going to say just very quickly I know some folks are joining who are part of the co-design program. Some folks are joining who may not know anything about Clew at all, or may not know, maybe just saw a link on AppleVis or Reddit and decided to jump on this presentation. So I just want to say really briefly, what is Clew? Because that's going to set the stage for some of the talks that you're gonna listen to. So Clew is an application that uses your smartphone to record routes in indoor environments. And crucially, these routes don't need GPS in order to be recorded. So it uses your phone's camera and the sensors in your phone in order to track your phone's motion as you move through space. Once you've navigated along a route with the Clew app, you can stop the route and save it so you can use it later, or navigate back to your starting position. So this could be useful navigating unfamiliar environments. For example, if there's an environment where you interact with like a sighted guide to go somewhere, you can return on your own to your starting location, or there might be an area that's difficult to navigate using traditional orientation mobility skills like using a cane. And in that case, Clew could help guide you. So Clew is always meant to be used as an augmentative tool to cane or a guide dog, and not as a replacement. And so it's really been designed around that use case. So one important feature of Clew is the ability to save routes. And several of the students are going to be talking about this in their presentations. But the idea is when you record a route, you do something called anchoring, where you take your phone and physically place it in a location, create an anchor point, record the route, and then the route is saved in reference to that anchor point. And whenever you want to go back, you place your phone in that same location, activate the anchor point procedure, and then go along the route. So that's a basic overview of how the app works, and we've been working on various aspects of how to improve that with feedback from the co-designers. Fernando, you want to say a few words about the co-design program and that sort of thing? Yeah.
Hi, everyone. Welcome. My name is Fernando Albertorio, and I've been working with Paul Ruvalo throughout the research program. The demo day is a culmination of our 10-week research program, so congratulations to our research team who's been working on various aspects of the technology platform. Because Clew is a smartphone app, what we've created is a technology platform that enables us to capture data, or what we call rich data, directly from the user, obviously with permission from the users, to improve the performance of the app, but also understand how the app works in the context as it's being used by someone who is blind or low vision or partially sighted. And so with our program over the summer, we have teamed up with co-designers from around the world. These are folks who are either technology enthusiasts, they're blind or low vision, they may be working in various fields in technology, but we also have representatives from various organizations for the blind across the world, people who are specialists and trainers in orientation and mobility. So we bring together a diverse skill set from within the blind and low vision community to actively take a seat at the table with our researchers and helping plan design, experiments, even feature development, and then providing feedback. So it's much more than just user testing. This program basically brings in folks from outside of our community onto the actual research team to then advance and accelerate the pace of the research that happened over these past 10 weeks. So we're very excited to share with you our research results. A lot of these projects are still ongoing, so what you're hearing is basically stuff, results and progress that is still continuing, and we wanted to bring this to the community so that you can actually have a chance to participate, to learn, and then to also connect with us. So if you're new, we definitely encourage you to reach out to us. There are a lot of opportunities to join or collaborate in the future, and we look forward to hearing from you. Thank you.
All right, fantastic. All right, so first up, we have Declan Ketchum to talk about how to learning Clew.
So hello, my name is Declan Ketchum. I am an engineering student here at Olin and on this research team working on Clew. So I focused mainly on learning Clew and creating a Clew tutorial. Other people who worked on this team were also Zach and Lizzie. And then, so starting right off with some difficulties around learning Clew. As with any new app or technology, there is a learning curve.
What the hell? What the hell?
Sorry guys,
I've never heard this song before.
just X out of this.
Wait. All right. After that brief musical interlude, let me get back. All right then. Okay, sorry.
All good, all good.
Just make sure that the controls work. Okay. This is where you were, right?
Yes.
Difficulties using Clew.
Yes.
Okay, I think everything's good, right? Okay, I think we're good. All right, let's get going again.
All right, sorry about that. So back to difficulties with using Clew. As with any new app or technology, there is a learning curve to getting to the point where you need to get to the point to feel confident and comfortable using said technology. Clew is uniquely challenging because it uses augmented reality and needs data from your phone's camera. For Clew to work, it needs visual data of the space in front of you, which is not always intuitive, especially for someone who is not using visual information to move around anyway. In a study conducted in previous years, we found that people reported having bad experiences using Clew when their phone was not oriented vertically with the rear camera facing directly in front of them. This experience makes sense because the app uses data from the phone's camera to create a route. It also shows that we need to do something to improve the experience of using the Clew app. We also observed that it can be difficult for people to adjust the phone to the correct orientation without outside feedback, or practice using Clew. Another difficulty that we heard from our users and from our wonderful co-designers is that the anchor points in Clew, which Paul talked about, are confusing, especially at first, which makes many of the features in Clew difficult to access. So in creating a tutorial, the difficulties around using Clew discussed in the previous slide impact new users the most. Without being able to get help or explanations, many might download Clew and become annoyed and stop using the app because it's confusing or unintuitive features, which involve skills that might be unpracticed in new Clew users, such as holding your phone in a good position for the camera to be able to pick up visual data. We started asking how we could explain and teach Clew to new people in a helpful way so that they could independently gain trust and confidence in Clew. We decided that making a Clew tutorial could add much needed information about how to use Clew and what situations Clew is a good tool for. along with providing a way to practice the skills that would make Clew easier. Okay, so how are we going to go about teaching Clew? We learned from orientation and mobility instructors who have taught Clew to students that it is important to build and then practice skills. Teachers will often show students what it feels like to follow a Clew path before ever having them record their own route. However, if someone is figuring out Clew without help, there isn't a built-in way to practice using the app without jumping into recording your own routes, which can be frustrating if you're not necessarily holding your phone in the correct position, which could make the routes that you're trying to record not very accurate, or if it isn't clear that you have to record a route first before trying to follow one, etc. It could also be unclear to a new user what they would use Clew for if they don't have a good sense of what it can do and how it functions, or if they don't have a good sense of what its limitations are. When talking with our co-designers, we learned that some of the things they value when starting to pick up Clew were not being afraid to make mistakes and to make sure that you're practicing in familiar spaces so that you can remain safe and have more comfort while trying to learn this new thing.
Okay.
So some of the requirements of using Clew, all of these insights that I just talked about influenced our requirements of the tutorial. So one requirement is using multiple modalities. We all know that people learn in very different ways. And we also heard this from our co-designers. Our goal is to create a tutorial to provide a few modalities of learning, such as written explanations and interactive practices. We also know that people might not be interested in going through a tutorial, so we wanted to make it so that people could exit at any time and learn the app simply by experimenting on their own. And then they would also have the option of returning to a tutorial to get, specific explanation on something that they would want information on. Our second requirement is that the tutorial builds all necessary skills in an order and provides opportunities to practice. We want someone to be able to download Clew and run through the tutorial and come out of it feeling like they have a good idea of how to do everything in the app. It's also important that we that we explain Clew in order, where each thing that you're learning builds on what you've learned previously, and you have the opportunity to practice those skills. We want to make sure that we also want to make sure that users can access relevant information in the context of using the app. For this reason, we have a help button on the Clew main screen that exists on any page of Clew. And this help button will take you to a page of the tutorial that is relevant to what you might be trying to do. For example, if you're on the home page, the help menu would take you to the home page of the tutorial. However, if you're on the page of Clew where you start saving a route, the help button would take you to the saving route section of the tutorial.
Just click on the screen.
Okay. So here we're gonna go into how the tutorial is now. So on the right-hand side of this screen, there is an image of what the Clew tutorial homepage looks like. It has a button for each section that has contents of what you would learn. The sections are first an introduction to Clew that includes information on what Clew can be used for, along with some limitations and disclaimers about Clew. In this section, there's also an introduction to the tutorial itself. The next section is on holding your phone, where the importance of your phone's positioning is explained, and there's an interactive exercise where you can practice holding your phone in the correct position. Following that, there's information on finding and following a Clew path, such as an explanation of what it should sound like when you're on the Clew path, along with 2 short practice routes that you can try out without ever having to save a route. In the next section, there's information on using single-use routes, and followed by a section on anchor points. Anchor points are explained along with the importance of accurately aligning them. And then there was also an opportunity to practice setting an anchor point and then realigning to that anchor point that you set. The tutorial then gives you feedback on how close you were to the initial anchor point. After this, there is an explanation of saved routes, and then an explanation of where you can find your saved routes after they've been saved and stored in a list. And finally, there's a page on what the settings of Clew are and how you can change them. So here's an example of what one of these practices would look like. One second, I'm going to start a video. So this video shows the tutorial homepage. We're then going to click on the holding your phone section of the tutorial, where there's an explanation of why it's important to hold your phone in a specific way while recording and navigating routes. There are some buttons below that will take us to different pages, and we're going to click on the practice button, which takes us to an interactive practice page where there are instructions that say, here you will practice holding your phone in the correct position for recording and navigating routes. Click start and try moving your phone around. You'll see that the further you are from holding your phone upright, the more your phone will buzz. And when you get to the right position, there will be a success sound and you'll get a point. To get more points, you'll have to move your phone out of the correct orientation and back into it. To do this, or try to do this at least 3 times. So now that we know what we're going to do, we're going to press the start button. The video just needs to catch up with us here a little bit.
Tracking performance normal.
So right there, you could hear what it sounds like when you're holding the phone in the incorrect position. It makes a lot of, it like beeps at you. And if you were holding the phone, you would also feel some haptic vibration, which would kind of cue you to try holding it in a different position. So that's what that sounds like. Here, so if you heard that shift in the sound, that's what it sounds like as you're holding it more correctly. It starts beeping a little bit less. And here, this is the correct position. So just there, I got 1 point. I was holding it in the correct position and it gave me a success sound that accompanies 1 point. And so now I would have to move it out of the correct position and then back into the correct position to get another point. So when doing this practice, you would try and get 3 points, and then you would get a notification that you've completed the holding your phone practice, and you can continue to the next section. Okay. So some next steps for this tutorial is to get some feedback on how people feel about this tutorial and how they're using it in its kind of more completed state, and then push this tutorial onto the main app so that anybody who's using Clew can use it. And we also want to be able to collect information on how this works as a teaching method by conducting a study in the future. So that's all I have. And now are we doing?
Yeah, let's take some questions. We're going to do questions after each talk. So if anybody has any questions for Declan, just go ahead and unmute and you can ask verbally.
Hello, I had a quick question. It's really cool. The sounds kind of help, I guess, provide the more centering aspect and making sure that it's people record and follow correctly. But I guess, are those sounds not only in the tutorial, but when a user's working with it live? I'm just wondering if the sounds could be a bit like overwhelming or kind of competing with the user trying to listen to their environmental sounds.
Yeah, that's a really good question. So the example that I just showed is just an example for using the tutorial. It's to practice the specific skill of holding your phone in kind of like an upright position with the rear camera facing in front of you. So those sounds are not part of using the main Clew app. When you're using the main Clew app, you really want to be paying attention to the sounds, like you said, the sounds around you, and then also Clew itself gives you some audio feedback when you're on the correct path that you should be on.
Awesome. Cool.
Does
Thank
that
you.
answer
Appreciate
your
it.
question?
Yes.
Awesome. Thanks.
Any other questions?
Hi, this is Diane. And I don't have a question, I just have a comment. And I think this is awesome. I think this is really great and it's going to be extremely helpful. I know for myself, when I first started with Clew, I was like, I get it, but I don't get it. So this, I think, is really going to help a lot of people.
Yes. Well, thank you, Diane. Thank you for coming. And I'm excited for you to be able to touch the tutorial yourself and be able to check it out.
Thank you.
Good evening, Edwin here. Can I have a copy of today's presentation slides?
Yeah, we can. Yeah, we'll compile all the presentation slides and make them available. Try to do the best way to send it out to folks. I will post them in any public places I posted the link to the Zoom. I'll put them and also send to the co-design list.
Okay, thanks. And
Thank you.
is this app available already in other parts of the world outside of US?
Yeah, well, the app is available. I think in any country, any app, any country. So we have translations for Arabic and Spanish, but the tutorial feature that Declan's talking about, that will be making its way into the production app soon. But if you want to get your hands on the beta version of the app, you can certainly email. Maybe the easiest one to remember is clewapp@gmail.com. CLEWAPP@gmail.com. If you just send us a note there, we'll send you a link to download this beta version of the app if you're interested.
Okay, I will send you clewapp@gmail.com.
Yeah. We'll put the email address in the chat right now.
Okay.
Okay. Thank you for asking. Okay.
Can I ask a question, Paul,
Sure.
before we continue?
First, yeah.
All right, cool. Well, cool presentation and very nice to see these tutorial. Hopefully they'll come into the app soon. I'm just wondering, in case of holding the phone upright, is that do users experience that as a problem in some scenarios? Because we hear people that they have some issues holding the phone upright in, let's say, privacy sensitive areas, like, for example, the waiting room of a hospital, or people feel a little bit conspicuous filming around. So we're experimenting with holding the phone downwards and then maintaining tracking just on the sensors of the phone. Is that something that you guys are considering? Did you ask people if they feel a problem with holding it upright and filming around?
Yeah, that's a really good question. So the app definitely doesn't require you to hold it upright. We have found, and there's good technical reasons to assume that the tracking is better when you're holding it upright. And we do have both like observational data, but also logging data from the app that also supports that. That said, the purpose of the tutorial is really just to help the users, if they want to use it upright to get the maximum accuracy, this will help them learn that skill, but the app will not require them to hold it in that way. So
Okay.
it's really about giving them the choice and the training if they choose to use it in this fashion, and to understand that this is the way to get the best accuracy. But of course, they may choose to do a different method if it suits the requirements of whatever situation they happen to be in. Yeah.
All right, cool.
Good point. Yeah.
Yeah, thanks, Paul.
All right. Okay, well, I think in the interest of time, we're going to move on to the next presentation. So the next presentation is going to be from Arwa, who's had joined us this summer from Saudi Arabia. So Arwa, how about you go ahead and share your screen and okay, sorry. Okay, I've messed up. Okay, the next talk is actually a different talk. So we will move on to death prediction and machine learning. Okay, sorry about that. All right. Neil and Marwan are going to present this. I understand Mario, I may also be on the call. He's the other lab member who contributed to this. Okay, so guys, go ahead and sit down and you can advance the slides from this computer.
Sweet, sure, awesome. Hi. So I'm Marwan.
And I'm Neil.
And we are part of the depth prediction and machine learning team. Lovely. All right. So advances in machine learning over the last couple of years have allowed for a lot of new advancements in accessibility tech that weren't possible before. So some examples of this are Microsoft Seeing AI, which is kind of a multi-tool app where you can sort of scan your phone around and take pictures of the environment, and it'll give you a description of what's in it, or you can scan handwriting and it'll tell you, convert it to text. Things like Apple's image description through their own voiceover, where again, it can describe what's inside of an image, and auto captioning of audio. There's a few examples of machine learning's applications in accessibility technology over the last few years. And now, given all of this, we feel like we can use machine learning to improve our own accessibility apps. So currently our apps use Apple ARKit, and ARKit has a ton of useful tools, which we love to use, but they're closed source and not really modifiable. And specifically, scene depth understanding without a LiDAR sensor is limited. So we'll get into what that means specifically in a little bit, but basically right now, the ability of a phone to understand how far away an object is dependent on texture and the motion of the phone. So our main goal of the summer was to replicate LiDAR technology on a non-LiDAR phone. So some of the new phones like the iPhone 12 Pro and iPhone 12 Max or 12 Pro Max have LiDAR, or light detection and ranging technology. So a LiDAR sensor uses a pulsed laser to measure ranges of objects around a room. And this technology can be used to detect how far away objects are from the device with very high accuracy. Now, in phones with LiDAR, ARKit is capable of finding how far away objects are very accurately, but in phones without this technology, we don't get the same ability. So we really wanted to find out if we could replicate LiDAR technology on a non-LiDAR phone. So our main method to do this would be using a machine learning model to detect depth of objects in a single frame from just a single camera input. So a good way to think of this would be as like a software LiDAR, or using software to emulate what a LiDAR sensor would do. And with this, we can do a lot of things like obstacle detection and path correction in the Clew app.
All right, so before we get into more of our work, we wanted to define some basic terms and some ideas that we have been using throughout our research. Just to start off, what is machine learning? A simple definition of this is a method of analysis where computers perform tasks without being explicitly programmed to do so. So for example, like if we're going back to what we talked about earlier with image recognition, the phone that you are using is not necessarily going to be hard programmed to recognize a chair just because we gave it an image of a chair and we're like, this is what a chair looks like. It has to learn. A machine has to get an idea of what a chair is through training and processing. And so that's basically what machine learning is. Other applications of machine learning could be, for example, YouTube auto captions. So whenever someone speaks in a video, YouTube creates captions at the bottom of the screen that can read out exactly what the user is saying. Or another example of this would be facial recognition or detection. What is a neural network? Neural networks are important. We'll talk about why in a little bit. But a neural network is basically a computing system that is inspired by a biological neural network. So inspired based on like animal brains. And what we use specifically is something called a convolutional neural network, which is a neural network where the data that is being analyzed has a spatial structure. In our case, we are using images. So basically, we are analyzing images. So our goal is to create, our goal is to figure out the depth of certain objects in an image. So the spatial structure is obviously going to be the image. It's because each image has a height and a width parameter, as well as a color parameter, red, green, or blue. So basically, convolutional neural networks are great for image recognition software. An example of what a convolutional neural network would look like is MNIST. MNIST is a neural network that is designed to identify numbers that you write. There is a link to a representation of this software on the slide if you want to explore this more. The neural network that we use is called FCRN, Fully Convolutional Residual Network. This is the neural network that is used by our app. It was developed in 2016 by Iro Lena. And it is currently one of the best networks out there that can predict depth. So basically what it does is it takes in a monocular camera input and it outputs a heat map. It outputs basically an image with a lower resolution where each pixel represents the depth of objects in the image. It was trained on a data set from NYU, which basically encompasses a lot of pictures of rooms and common environments. Next slide. Okay, and finally, point clouds. Point clouds are also important. Point clouds are basically collections of points in 3D space. Why are they important? Well, point clouds can be used to conform and represent geometry. If you have a LiDAR phone, or if you use LiDAR technology, you will know that when a pulse laser hits an object, it can create a point on that object. And so basically, if a LiDAR phone scans an environment around it, you can create a point cloud of that environment, and that point cloud can show that point cloud can lead to scene understanding. So for example, if I scan a room, I will be able to tell that it is a 4-walled room. For example, it is maybe 16 by 20 feet. The point cloud will show the chairs and the different types of furniture in the room, and it will even pinpoint the specific locations of these objects. All right, so now let's dive into our current work a little bit. So we have created an app called Depth Viewer, which is created to estimate scene depth using the iPhone camera. It uses the FCRN ML model, which is basically the FCRN neural network conformed to an Apple Core ML framework. It takes in the camera input and outputs a depth heat map, which we end up turning into a point cloud for analysis. It provides voice and haptic cues for how far an object is from the middle of the camera. The next slide will have a demo. So this is the app in action. So I'm just going to freeze the frame for a second. What is going on? So in the video, we see there are 2 buttons on the top of the screen for meters and feet, depending on what unit of measurement you want to have the app read out to you. Currently, the app is being demoed in a classroom. In the image, there is a chair as well as a few tables and some cardboard boxes, and there's a back wall in the later frames. And below that image is the heat map that is being processed by FCRN Live. So in the heat map, it is a black and white image where the objects that are closer to the camera are displayed in whiter pixels, and the objects that are farther away are displayed in darker pixels. So
feet 4.2.
So this is
4.5.
So I've selected feet as the unit of measurement, and I am backing away from the chair.
6.5 meters.
So
1.9.
Wait, that is so loud.
1.9.
So as I was backing away from the chair, the voice started to display that I was backing away from the object by saying that the distance was getting bigger. Now I've turned my camera towards these cardboard boxes and switched the measurement to meters. So as I get closer to these boxes.
1.5.
Yeah.
1.6. 1.1.
Yeah, so as I got closer to the boxes, it started to see that we were getting closer to the boxes by changing the depth. Okay. There we go.
So thanks to our meetings with co-designers, we were able to get a lot more clarity on what we should do with the future of this app. So first off, one of the ideas we got are having separate orientation and mobility modes. So an orientation mode could be where you use the FCRN technologies, and it helps you create a mental map of the room. So we'll give a user a description of the space, how many walls are in it, where exits are, etc. And another option is the mobility mode, where this would be more geared towards if you're moving through a space. It can detect and identify objects in your way using object recognition and help you stay on the same path. In addition, we're also looking at introducing object recognitions from point clouds themselves. So being able to look at a cluster of points and define it to be a couch or some piece of furniture. And also we want to eventually implement all these features in Clew. So another thing we're looking at in the future is expanding on the FCRN model. So as Neil mentioned earlier, it's trained on NYU depth data. And while this data set is great, it loses some specificity and granularity at closer distances, and it doesn't have the range that we want it to. So we want to find a training set that's closer to what a Clew user will find in their daily use and get more specific longer range heat maps to make our predictions better. In addition, we want to add in some extra parameters that are relevant to us, such as phone pose. So if someone's pointing their phone down versus pointing straight up, we might want to give a different type of depth reading. And finally, we're working on a neural network called PointNet. So PointNet segments point clouds, and we're right now in the process of retraining this. So point cloud segmentation is essentially, it can take certain points in a point cloud and define them to be objects. So it can say these points make up a wall, these points make up a couch, so on and so forth. So right now we're trying to retrain these because PointNet is designed to find furniture from LiDAR scans. We want this to be able to find walls and floors from our non-LiDAR FCRN generated point clouds. So doing this will allow for us to gain scene understanding and do on-the-fly routing to objects and correction. The only issue right now is it's not integrated with iOS or Swift, but this is in development right now. And thank you all so much for listening to our presentation.
Yeah, and we'll open it up to questions now. Our emails are down below if you want to contact us later. Thank you.
I had a question. I'm curious how the software LiDAR is accuracy is compared to like the hardware LiDAR, and if for LiDAR devices will it be able to use that? And then in terms of the feedback, are you just sending like a speech announcement to VoiceOver? I'm curious if it will work with Braille and if there are any like haptics or sounds associated with those kind of distance announcements to provide like non-speech equivalents.
Yeah, so we have two options. So the build we showed, it sends out a voice command to VoiceOver where it says the number of meters, but we also have another method implemented where it sends out a haptic where it'll basically buzz with a frequency based on how far the object is from the camera. And as far as the non-LiDAR point clouds, so they're not as accurate or as specific as LiDAR point clouds, but they do a good job of giving us sort of a general idea of how far an object is from the camera. So where a LiDAR point cloud kind of will really clearly get the corners of an object, the non-LiDAR ones will sort of get a lump in the area. So it'll know like how far, like the general, how far an object is, but it doesn't get the same specificity.
I have a question. May I ask it?
Sure.
So I noticed, I think what I heard during feedback when you were moving towards and away from objects, it seemed like it switched from feet to meters at one point. And then at one point, it didn't sound like it was announcing either feet or meters. How much is that is controlled by the user? And if you could just explain a little bit about why I heard those changes.
Sure. Yeah. So I think I could have explained this a little bit better, but at the beginning of the demo, I selected feet as the option. There were two buttons at the top of the screen, one for meters and one for feet, so you can toggle in between the two. And we have programmed the app so that it just reads out the numbers instead of the units at the end. So when I pressed feet at the top, it read out the distances in feet, and then at some point I switched it to meters, and so it started reading out the distance in meters.
Thank you.
Yep.
This is Rick.
Yeah, go for it, Rick.
Are you developing this to use both LiDAR and non-LiDAR?
Yeah, so we will moving forward. So right now, all the technologies were sort of like the PointNet and point cloud segmentation. This is all stuff that can be done with our non-LiDAR, simulated LiDAR or actual LiDAR phones. So it kind of goes both ways in our development of this.
So if you have a LiDAR phone, it will actually utilize that LiDAR technology now in the app, or is it in a release to come?
Right. Yeah. So if you have a LiDAR phone, you won't really need you won't have a need for the software LiDAR. So yeah, you'll just stick to using the LiDAR.
Yeah. I mean, I think right now in the build, it might not be using it, but that would be the plan. Like going forward would be to like kind of select whichever, if the phone supported LiDAR, it would automatically use it.
Yeah.
But just we're at a pretty early stage with this one. So we haven't implemented it yet.
Very good, thank you.
Okay,
yeah, of course.
All right, I think the interest of time, I think we will move on to the next presentation. Okay, so now I'll invite Arwa, sorry about the false alarm earlier, to share her screen and present her work on hands-free usage of Clew.
Right, so hello everyone. My name is Arwa Najashi and I've been working on Clew hands-free feature over the course of the summer. So let's get started. So to start off, I started with the vague question of how can I improve the user experience of Clew. I have deployed the design thinking approach to better understand the problem and put the user at the heart of the solution. So this consisted of 6 stages. And the first stage was empathizing with the user. So at first, to understand what the user is going through, I conducted the research to understand the previous identified problems. The main one was with the phone pauses and holding the phone in place. This problem not only arises in Clew, but also it arises in other AR ARKit applications. So it's an accessibility issue rather than Clew issue. So the second step was conducting user research. I have interviewed a couple of existing users, and we have validated that holding the phone vertically is indeed an issue. And also we have learned that users have new techniques of overcoming this issue. So the first one is using an additional accessory to stabilize the phone in place. And the second one is using a technique that is used in photography, which consists of bracing the phone vertically against the chest. So that way the phone is held in place and the tracking accuracy is improved. So moving on to the next slide. Having learned that from users, we have found the room to introduce a new interaction methods with Clew that will facilitate these 2 methods of using Clew, the bracing method and using an additional accessory method. So I have then compiled a list of personas that captures the user needs and major pain points, which has been then used in things like testing. So the main requirements is using voice commands and also like having a smooth user experience. So AKA finding an alternative way to setting an anchor point rather than setting a physical anchor point when it comes to using voice commands. So here is a summary of the problem and the solution. So the problem is we need to improve the use of Clew for those who find holding the phone vertically difficult. Why phone verticality? Phone verticality is crucial for optimal performance of AR applications. So the solution consists of integrating Siri shortcuts into Clew to give users the option to either attach their phone to a lanyard or use the phone bracing method. But not only that, adding Siri shortcuts will also allow for a faster means of interacting with the app and facilitate other users. So I have then mapped the user requirements to a system requirements, which is presented in the slides here. I'm not going to go into details with that. So here is a quick demo of the presentation of the Siri shortcuts.
Start single use route.
This video has showed me holding the phone vertically against my body. Okay. So this video has showed me holding the phone vertically against my body. The camera was facing forward and I used Siri shortcut to start a single use route. I didn't have to interact with the screen. It was all through using voice commands. All right. So moving to the next slide, we needed to find a way to validate the accuracy of tracking with using the new methods. So we're introducing a new interaction method that is voice commands. So would Siri interfere with the tracking performance? That's the question that we're trying to understand, and also would attaching the phone to a lanyard interfere with the tracking as well. So we're designing a within participants experiment design with 3 conditions of racing, using the lanyard and holding the phone vertically. We're then gonna conduct a bunch of analysis with the gathered data to understand if the tracking performance is consistent, and thus this feature could be added to a stable version Clew. So prototyping, I have followed a advocate UX principles. So just the main one that people err, and so we need to provide means for users to go back and like change any decisions or choices that they may have made. And also accessibility. The app need to be accessible for all users. So yeah, here is the slide that shows some screenshots of the app that contains the experiment and the Siri shortcuts. So I have introduced an experiment button that will guide the users through the set of experiments, and it will give them a step-by-step approach to be able to follow the instructions precisely. And I also showing a screen that presents how the Siri shortcuts will be added. So that is through a prompt that would say add to Siri, and then the user could enter the phrase that they want, to be mapped with the action that they press. So say if they press on a single use route, they get a prompt saying add start a single use route to Siri. If they want to change this option, they have the choice to do that, or they could choose the default option and use that throughout. Also, we have added the tab that shows the Siri shortcuts, as people may forget what shortcuts they have added and want to go back and refer to that. Also, like an app survey to measure things like user performance and user satisfaction and usefulness of the methods. Finally, testing. The first step is a cognitive walkthrough. So this involves us putting ourselves imagining ourselves from the point of view of the personas, and taking a step-by-step and following a step-by-step process to interact with the app. That will allow us to identify any bugs before sending the test version to the co-designers. This has certainly allowed me to identify many bugs and issues, mainly like I have added the Siri shortcut list, as I have been given feedback that it is hard to remember shortcuts. So this feature was added after the cognitive walkthrough. So this shows the importance of doing various testing before giving it to co-designers. And then through user feedback, this is currently being conducted. So we've got some positive feedback of users saying that they love using Siri and it enables them to use Clew in a faster way. We have also got some concerns that Siri needs an internet connection, which might not be available all the time. Also, some suggestion to introduce an Apple Watch application to allow for haptic feedback. Moving on to the implementation and what are the next steps. So firstly, let's discuss what are the limitations with this approach. So using voice commands means that the hands-free use is not accessible for blind deaf people. So we need to identify a way to make this applicable. Also, the current proposed method of anchoring, of setting an anchor point with the hands-free feature is through visual alignment, which is a method that has been introduced 2 years ago. However, this has a lot of challenges as it uses visual features from the environment to match it with the previous recorded route. And if the visual environment changes, then the route might not be recognized, or if like it has been traveled from start to end, from end to start rather from start to end, the anchoring might not be proper as the camera is viewing the object from a different orientation and might not recognize that this is actually the same object. So this has a lot of challenges. So yeah. So how does the hands-free system improve Clew use? It keeps the phone vertical in place, potential for an improved tracking accuracy for people who suffer, for users who find holding the phone particularly hard. Also provide faster means of using Clew. Also, there's the potential for a lower learning curve when using Clew for the first time, as we have learned that Siri is the go-to methods for like people who are new to blindness, and it's definitely intuitive and easy to use. So the introduction of Siri could also make Clew easier to learn in the long run. So yeah, what are the next steps is conduct the experiment and analyze the data. If we find that indeed this method doesn't interfere with tracking and the users are satisfied with it, then we could start implementing Siri dialogues, which means that Siri would be able to actually take inputs from the user and interact with them rather than just taking one phrase or one shortcut at a time. Also research other modalities of facilitating hands-free. So this means including blind deaf people, but also like allowing people to use hands-free in silent or quiet areas like libraries. We have got some suggestions of adding commanding Clew through headsets and headsets or the Apple Watch. So we should look into that a bit more and see if that's valid and how we could use the Apple Watch with Clew. Also look into how we can improve methods of setting an anchor point. As I have mentioned, the visual alignment is there. However, it doesn't succeed most of the time. The next presentation is going to discuss anchoring of app clips. This could also be integrated with the hands-free features to also allow for hands-free use. I'm not going to go into details with anchoring of app clips because they're going to go next and give you a bit more details about that. So yeah, thank you so much for listening. If you have any questions, I'm happy to answer them. Here are my contact details. I'll also send them in the chat if there are any questions, and thank you.
All right, thank you, Ara. We have time for a couple questions.
Hi, this is Hanif from South Africa. May I go ahead?
Yeah, go for it.
Okay. Well, in your thing, have you considered using additional hardware devices to perhaps actualize and solve the problem of people being able to point the phone in the correct direction. I'm thinking something in the line of a camera being worn on a frame of typically glasses. That's it.
Yeah, I understand this. We have conducted various of market research, and a lot of assistive technology apps use external glasses with cameras. However, this introduces another barrier of cost, like these glasses could cost a lot. And so by providing users with the the stereo shortcuts, they could get like a lanyard off Amazon, which only costs $20 or less, and be able to put the camera on the phone and use, which is like pretty powerful. And I don't think that a camera used in a glasses would perform better in any way. So yeah, while using glasses is valid, we don't think it's cost effective or would add an additional value to our users at this point.
Curious which lanyards you. So I have one here. Just like where the phone. This is where the phone goes, and then it's kind of more of a rubbery silicone one that tends, when I'm walking, it's not really that stable. Kind of moves around quite a bit, and the phone flips. Did you find one that is more stable?
Arwa, I muted you just because we had some. So please unmute yourself.
Yeah. Sorry, I also actually just wanted to just back up what I was saying, and I'm sorry if I'm intruding here, but it's really difficult for us to wear a phone carry a phone in public. It actually makes you a target as a blind person, especially in the setting that we're in. People will have their phone snatched right out of their hands. There's no doubt about that. So basically making that's another barrier for us then as well. Whereas something as simple as, and it doesn't have to be expensive, but a sort of wearable device would make a lot more sense. And I do believe there could be some ways to look at costing those kind of things. But I'm just to explain where my questioning comes from. Thank you.
I think that's really a very fair point, and I think exploring that type of solution is something that should be done. We haven't tackled it yet. It's a big task, but I think you're absolutely right that there's a lot of reasons why that solution makes a lot of sense. And then to Kevin, your point, the lanyards do kind of move around a lot. We haven't found that influences the tracking all that much, but that's part of what we're hoping to test in the experiment. I'm sorry, Arwa, I see you're unmuted now. I didn't mean to take over for you. Do you want to answer also that question?
I think you've covered most points. So
Okay.
Yeah, thank you.
Okay, great. I think actually, okay, I guess we have maybe one more question. Anybody have a question? Okay, all right. Well, we're going to move on to the next presentation. So I'm going to go ahead and share my screen again. Where are we? Okay, so I'll introduce Esme Abbott and Berwin Land to talk about their work with shareable routes through Clew maps and app clips.
Hi, everyone. I'm Esme. And I'm Berwin. So this summer, we've built an extension of Clew that we're calling Clew Maps. Clew Maps builds on the existing functionality of Clew as an indoor navigation app to better support sharing routes and navigating unfamiliar spaces. There we go. So first, we'll start with a brief introduction of the technology that this project is built on, as well as the goals and motivation for the work.
Yeah, so currently the way that route sharing is implemented in Clew, it's very underutilized for a few reasons. So some of the major pain points of the way it currently works is that, first of all, it's difficult to communicate the location of the anchor point to someone else. And there isn't a lot of room for error for setting an anchor point and aligning to a route. And lastly, you can only share one route at a time. So the way that Clew Maps attempts to fix this is by using a cloud database as a repository for all these routes. So this way, route creators can upload these routes to the centralized location, and route users can download routes from there as well. In addition to that, we also introduced this new image anchoring method for aligning to a route that replaces the way it currently works. So in addition to the cloud database that stores the routes, we realized that there is a need for a means of distributing these routes to people, and that is where app clips come in. They're a relatively new addition to iOS. They were introduced about 2 years ago, and they're lightweight versions of conventional apps that can be launched quickly, and they're only temporarily stored on your device, as opposed to an app that would persist. A huge part of app clips is that you're able to configure more than one local experience that's tied to a specific location. So for a coffee shop, this might mean they're able to display different menus to a user depending on what store they're in. But for us, we think that there's really strong potential for navigating public spaces, in that someone could scan an app clip in a store and it would take them to a list of routes that are specific to that store. And if they were at, say, an airport or a transit station, they'd get a different set of routes. And then the way that app clips are actually loaded onto your phone is by using something called an invocation URL, which is essentially something, it works pretty much like a regular URL, except it links a specific website to a specific app. So in this case, you would open an invocation URL that points to Clew, and then the Clew app clip would be downloaded on your phone. And then these can be accessed by scanning an app clip code on your camera, which is sort of a visual code that stores information similar to a QR code. You could also read an NFC tag, which is like a physical way to store information that you can tap with your phone to load the invocation URL and app clip, or you can open an action in Apple Maps or in Safari. Next, we'll talk a little bit about the user workflows of Clew Maps. In Clew, the assumption is that kind of users function as, or users act as both a navigator and a recorder of routes, and in Clew Maps, those two have been separated out from each other because of that cloud database option. So first, we'll talk about Clew Map creators. The first step for them would be a physical setup, so choosing a location to start their routes for and reaching out to the Clew team to get an assigned location. Next, the creator would enter a cycle of recording and validating routes to ensure that they have quality routes that others can then navigate before they upload them to the cloud database. And next up, we have the role of the navigators. We've been working really closely with co-designers on this aspect of the project, and are super thankful for their input. First is a discovery phase, where a user either enters an unfamiliar space or learns that there are these Clew Map routes that exist in a space that they're planning on going. And currently, we believe that these can happen in either order. However, there seems to be a preference for learning that the routes exist before entering this space. The user would then invoke the app clip code in a way that Berwin mentioned earlier, either scanning a visual code or an NFC tag, select a route from the list of routes that are specific to that location, and then localize, which is something that I'll discuss as we go into the technical implementation. So anchor points are something that have been discussed at length, but they're really important because route data such as waypoints are stored relative to the starting point that can be inconsistent between sessions. So a way to think about this is, if I was told to walk 3 steps forward, I would end up in a completely different place in my current location compared to if I was 2 feet to the right pointing left. I would end up in a different location and wouldn't get to my end goal. So anchor points are necessary because you need a fixed location in space to align your position when you were recording your route to the position where you were navigating the route. So in traditional Clew anchoring, the fixed location is the location of the phone. This is something that Declan talked about in the tutorial, but it means the user is responsible for the accuracy of the alignment. And we've learned that anchor point location can be really difficult to communicate asynchronously because it depends a lot on someone's preferences about how they set anchor points and how they use their phone. So rather than rely on a physical location of the phone for anchoring, Clew Maps uses an AR image anchor as the fixed location. This is a 2D image in space with a fixed size, and
when Clew starts collecting camera data, it's able to detect where this image exists in space and return the position of that image. So regardless of where you are relative to the image, if the image can be detected, you can figure out where you are relative to that, and thus where you are relative to where the route was recorded.
Yeah, so as we kind of discussed earlier, Clew Maps separates the workflow of route recording and route navigation. So the first of these is route recording and uploading. So when you record a saved route, a bunch of data is saved, and that can generally be categorized into either identifying data or navigation data, where identifying data will help distinguish a certain route from all the others. So this would be the route name, the route ID, and a 3-digit route code ID that corresponds to the starting point of that route, and all other routes that start from that point. And then on the other hand, navigation data is what actually gets you from point A to point B. So that would be the path of the route. And then the location of the phone relative to the image anchor that was discussed on the last slide. And then all this is uploaded to this cloud database with one file storing the identifiers of all the routes with the same code ID. So all the routes that start in the same place. And then there's also one navigation file per route. And then the second process is for the route navigator who downloads and then navigates the route. So the user will either scan an app clip code ID or an NFC tag, or somehow open up the Clew Maps navigation functionality and input a 3-digit code that corresponds to the starting point that they're at right now. And then from the cloud database, the identifiers file that corresponds to that starting point is loaded. And then a list of all the possible routes that start at that starting point are shown to the user in a list. After that, the user can read through that list and select the route they'd like to navigate. And then back in the cloud database, the selected route name is linked to a route ID that corresponds to that route's navigation file. That navigation file can be downloaded to the user's phone, and then the route's loaded and navigation can begin. Yeah, so compared to Clew Maps has a few changes in the user interface to reflect some of the technical changes that have occurred.
And we'll be going through a video demo later. We just wanted to provide some context for the screens that appear in that demo. So first up is the user interface for creating a route in Clew Maps. In Clew, the first step was to set an anchor point, but in Clew Maps, the first step is to associate your route with that 3-digit code that Berwin talked about earlier. This can either happen by inputting a 3-digit app clip code ID just in a text field, or pressing a button that says scan NFC app clip code. And that would allow a user to touch an NFC tag, which is a way of storing data that most modern phones can access through touch. It stands for near field communication. And after that process is set up, the user can go on to navigating a route, or recording a route rather.
And then the user interface for setting an anchor point when you create a route is also slightly different. So in the current version of Clew, it relies on your phone being in the same location each time. So there's a countdown timer. And then in Clew Maps, there's this new screen that pops up that'll ask you to scan your phone, kind of like pan your phone from side to side until your camera is able to pick up a 2D image anchor in the environment. And then once the camera is able to identify that image anchor, it will put a green plane over the image and also prompt you to start recording with a popover.
And then the rest of the route recording process is very similar to how Clew works previously. And then the next step in the kind of route creator workflow would be the route manager view. This is similar to the saved routes list in Clew, which is presented on the left-hand side of the screen. In the saved routes list, a user can either click to start navigating a route or swipe to share or delete a route. And we've transitioned this into its own page with 4 different buttons. So you can navigate or test a route, you can delete a route, share a route, all of those were pre-existing. And then we also added the upload route button, which sends a route to the cloud database once it's been validated.
And then aligning to an anchor point looks very similar to how the screen looks when you are setting an anchor point. You'll still be asked to pan your phone from side to side until your camera finds the image anchor in your environment. And then once it does, a green plane will appear. There will be an audio cue, and then you'll automatically start navigating the route.
And then the last key difference between Clew and Clew Maps is the process of selecting a route from an app clip invocation. So after a user opens the app clip or enters the 3-digit code, a list of routes pops up, and from this list of routes, a user can select one and confirm their choice by touching a Start Navigating button.
And then the final thing we wanted to talk about before the demo were some of the limitations of this and where we wanted to go from here. So one limitation was that the anchor reference images needed to be included in the code base, and they need to have a set size. So something we wanted to look into was the possibility for route managers to upload their own anchor images instead of using the one that we coded in. And the second thing is that anchor discovery can be difficult, which is something that we learned from talking to our co-designers. So in order to address that, we wanted to explore other possibilities like tactile images, NFC tag anchoring, or GPS-based navigation to the start of the route. And we also want to be able to quantify how robustly these image anchors can be detected.
All right, so this slide is a demonstration of the recording, uploading, and navigating functionalities of Clew Maps. The video has a camera feed of Berwin recording a route, or Berwin completing these tasks on the left-hand side, and a screen recording on the right-hand side. We have voiceover turned on in the screen recording, and also a narration of what's happening in the video. So please let us know in the chat if there are any issues with the audio.
First up is a demo of recording the route. The first step of recording a route is to enter its associated app clip code ID, which is the 3-digit code that tells where things are in the database.
Scan NFC app clip code button.
Here, Berwin's doing that by scanning an NFC tag.
Enter text to help you remember this app clip code ID saved. You may now set an anchor point. Successful alert. Start recording.
Next, she aligns to the image anchor and starts
Click start to begin recording route.
process.
Start button. Stop recording. But anchor point saved. You are
rest of
recording a route.
recording looks
Hold
like
vertically with the
recording
rear
any
camera
route
facing forward.
included.
Stop. Clew home screen. Route success. Enter route. Save route. Enter route name here.
Berwin's now
Text
stopped
field.
the
Insertion.
route and is naming it
Cat T.
to upload
S.
to the database.
S. T. T. Save route name. Clew home screen. Route. Load routes from app clip.
Next up is uploading a route.
Voiceover on. Clew map. Access the routes on your device. But access the routes on your device. Local save. Route test. Button.
Uploading a route is done through
upload
the
route.
route manager
Button.
view. Lastly, we have navigating a route. Since
Load routes
Berwin's
from app clip code
navigating
ID.
through the app
Button.
rather than the
Load
app
routes from
clip,
app clip code
the
ID.
app clip
Scan an
URL
NFC
hasn't
app
been
clip code.
invoked yet, so
Button.
she's having to add
Ready
in
to scan.
the app clip code ID manually.
Successful. Left turn. L.
Now
Right
she
turn.
can select
Test.
any of the
Button.
routes that have been
Test.
uploaded to this location
Start navigating.
in the database.
Start navigating. Please align your device with the camera pointed at your anchor image. If you are using the Clew app clip, this will be in the same location as the scanned app clip code. Your route navigation will start immediately after your device has anchored to the image. Stop
After
navigate. Turn
scanning
left.
to
Align to
locate
anchor
the
point. Starting
image
navigation.
anchor, she's automatically aligned and can begin navigating just like a normal Clew route.
Record voice node. Button.
Great.
First up is a demo of
There we go. All right, thank you so much. That wraps up our presentation, and we can take any questions now. I think we had one in the chat earlier asking if Clew Maps was separate from Clew. Currently, it is built as a slightly different app because of the way that app clips have to be associated with a specific app, but the hope is that as we continue to work on this project, we'll eventually be able to merge the two into one app.
If there are any other questions, we can also take them.
All right, okay. All right, if anybody comes up with a question while the next group is getting set up, just feel free to jump in. All right, so our last presentation of the day is going to be the Invisible Map Group. This is going to be a presentation by Ben Morris and Allison Lee.
Okay. Hello, everyone. Thank you for coming to our demo day. We are the Invisible Map team. My name is Allison.
And my name's Ben. So what is Invisible Map? Invisible Map is meant to be a map of an entire building. This contains the position and orientation of markers throughout the building, the position of breadcrumbs or places you can walk within the building, such as hallways or inside rooms, and the position of name locations, such as specific classrooms, the bathroom, water fountains, etc. So the idea is that while routes like in Clew can navigate you from A to B, and they have to stay directly on the path, and they can't kind of inform each other. So for instance, if you had two routes in the same building that overlapped, they wouldn't be able to learn from each other. So the idea is that maps can be from anywhere to anywhere within a specific building. And because of just the nature of hallways and branching, this means that it can allow for detours or helping you when you get lost. And because it's one kind of collection of information with essentially a ton of different possible routes you can take, it's a much more efficient use of information.
So the markers that Ben mentioned just earlier are called April tags. They're essentially these small codes that are similar to QR codes. It's an 8x8 grid of black and white squares. They all have a very unique pattern, so they're easily identifiable. And the most important thing about April tags is that the phone can easily identify the position and the orientation of the tag. So similar to the image anchors that the previous group was talking about, the phone is able to identify where this tag is as soon as it detects it within the camera frame. And the big useful thing of that is that if you chain April tags together, so you detect one and walk some more and then detect another, the phone can store the locations of these tags. And then when you re-navigate your route, if after scanning the first tag, the path starts to drift a little bit as you walk further, as soon as it scans the second tag, it can reorient the path and put it back on the right track. This is a big disadvantage that happens in Clew, which is that because Clew does not have any relocalization, sometimes the path will drift. So this allows us to make much bigger paths through a space.
So the Invisible Map suite has two apps, Invisible Map and Invisible Map Creator. Invisible Map Creator is an app to help people create these maps. So very similar to Clew, users will walk through an entire space. They will also have to record tags that they have hung up around the space so that we can learn the location of them. This is also where users will save locations to name and come back to. In the future, it will be where you can edit maps and change locations. And finally, it's where you can upload the maps for processing. Invisible Map is for people who want to navigate the maps. So you can download public maps, download your own maps, eventually share maps with friends. And this is the much more Clew-esque app where it can navigate you through the building.
So before we came onto this project over this summer, there was a lot of previous work done on Invisible Map, but we did identify a lot of issues right at the beginning of the summer, which is the main issue is just with map accuracy. And so our first step in starting to tackle these issues is to improve the raw data from the map. So the big problem that we had with the raw data that comes straight out of Invisible Map Creator is that although the April tag position and orientation detections are relatively accurate, sometimes it would be a little bit off or have outliers that would jump out. And oftentimes it would be off by tilting off of the wall by a few degrees, and even just a couple of degrees tilt off of the wall can throw off the rest of the map because that will cause all of the paths to tilt. And so we identified that as a big problem that we needed to fix. The solution we came up with is to harness the power of LiDAR. So as the depth prediction team was talking about, LiDAR is very powerful, but the big con is that it's only available in the iPhone 12 Pro, Pro Max, and the most recent iPad Pros as of right now. But we decided to continue with focusing on LiDAR because only the creator of the map needs to have a LiDAR phone. The users of the map later that need to re-navigate it do not need to have a LiDAR phone. So therefore, the burden of having a LiDAR phone is only on the initial map creator and not on everyone else. And we've had such good results with it that we decided it was worth keeping. And so on this slide, we have two images that have that are screenshots from an app that demonstrates what LiDAR can do. So it's a visualization of the LiDAR mesh. And what the mesh is like if you imagine putting a big blanket over everything in a scene. So in the first image, there's a table and chairs and like a whiteboard, and the mesh sort of covers over all of these. And so the phone can detect exactly where these objects are and how far away they are. And the big thing that we wanted out of LiDAR is that LiDAR is very good at detecting flat planes, so like floors, walls, ceilings. And so we wanted to harness that power. In the second image, we have a picture of a wall with the mesh, and it has this very nice flat mesh against the wall. And so we use a technique called ray casting, which is if you imagine you shoot a ray from the camera of your phone toward in a certain direction. And so in our case, we shot it in the direction of where the phone initially thinks the tag is, just based on visual data. And then it would use the LiDAR data to detect where the wall is in the direction of the raycast, and then it would place the tag right on the wall in that position. And what that allows us to do is more accurately estimate where the tag is. And in that way, we would reduce the amount of error and also reduce that tilting that I was talking about earlier. And so on the next slide, we have a picture with a visualization in the Invisible Map Creator app of the raycasting of the tag. And there's a little box that appears over the tag as soon as it detects it. And in this image, the box is right on top of the tag. It's oriented perfectly. And so we got really, really good results with this raycasting. And so that caused our raw data to be much better. And then in return, the process data ended up being better as well.
Yep, so after we improved the quality of the data, we started looking at taking paths through the maps. Because currently the map is just one single long route that lightly intersects itself at points. So it could only really navigate from start to finish across the same route that the mapper took to make it. So we built on the path planning algorithm and ability to detect intersecting paths that previous researchers had worked on before us, and actually managed to implement that into the Invisible Map app. So on screen now is a picture of an example path where the user is at the top of a set of stairs and the path is directing them down that set of stairs towards their final destination. In the final version, this will have both audio and haptic feedback to help.
So we have a demo of Invisible Map Creator and Invisible Map. When I walked the Invisible Map route, I essentially first started up the app. And then as soon as I open up the app, it comes to a list of maps. And then from there, I can select create a new map. And then that will bring up my camera. This video is sped up for the sake of time. It brings up my camera, and the first thing that it instructs me to do is point my camera at a tag. So I point the phone at a tag, and as soon as I point it at its first tag, once it detects it, it displays a visualization and also instructions saying that you found your first tag. And then there's a button that says start recording tags. I hit that button, and as soon as you record a tag, it will add it to the map and restore its location. Then as you continue to walk along, the same process repeats. So every time it sees a tag, it displays a visualization, lets you know, you hit record, and then it will store the tag position. What you can also do is store locations. So I also add a location at the women's bathroom by hitting the add location button, typing a name, and then hitting save. That will drop a pin at the women's bathroom, and then later on I will be able to come back to that. And then I continue along using the creator, and then at the very end, I circle back to where I start, record my final tag, and then save the map, give the map a name, and then this will upload it to the backend processing. Then in Invisible Map, I start up the Invisible Map app. So in a couple minutes, it finishes processing. I start up Invisible Map, and it pulls up the same list of maps that I've created. I can find the map that I just made and click on it, and then that will start up the app. And then there's another button that says start tag detection. As soon as I click that, it will start looking for tags in the camera frame. So it finds my first tag and it plays that little audio cue. Oh, what? Sorry, the video just glitched out a little bit. It plays the little audio cue at the beginning that indicates that the navigation has started. Currently, there's no verbal feedback, but there is audio cues and haptic cues of a beeping. This video is also sped up, but the stronger the audio cues and the haptic cues, the more aligned you are with the path. It shows the same red path that Ben was talking about previously that navigates you to your destination. And the big important thing to notice in this demo as well is that when I initially scan the first tag and I start walking, the path starts to drift just a little bit as I continue to walk, but then my phone passively detects the second tag. And as soon as it detects that second tag, it moves the path to be back in the right position because it knows where that tag is supposed to be. And so it shifts everything back in place. And then so that's that live correction that we were talking about that allows longer routes to work. And also, as I pass by the women's bathroom, the little location marker that I put there is also there. And then I just walk the path all the way to the end, and at the end of the path, it also plays an audio cue to indicate that I've arrived.
Okay, so after all this is done, we are looking into implementing a potential new feature called floor detection. So the current way that the app will figure out if you can kind of jump a section of the path is if there is an intersection between kind of two points in the path. This works sometimes, but not all the time. For example, in the demo, there was a point where the path kind of dipped into an alcove and then back out, where it could have just gone straight. So we hope to use the power of ARKit to figure out when 2 points are connected by a single stretch of floor, and that way it can eliminate that need to go into the alcove and back out, for example. So on the screen are some examples of the final algorithm that we made for this. So each image has 2 pins, either red or green. Red pins are pins that are not connected by floor or are too far apart, and green pins are pins that are connected by floor. So the first image has 2 pins, one's hidden behind the other, that are too far apart, so they've turned red. The second image has 2 pins that are close enough together and there's no walls in between them, so they've turned green. And the third image are 2 pins that, while they are close enough together, have a wall kind of separating them, so they are red as well.
So some of our next steps for Invisible Map are to add the ability to edit maps within Invisible Map Creator. So after you've created a map, you should be able to change like location names and potentially move where the locations are. We also want to, in Invisible Map, to be able to choose an endpoint. So rather than navigating to a fixed point, you can actually choose where you want to go, and it will bring you there. Also for Invisible Map Creator, the ability to pause map creation. Right now, the map creator needs to walk the entire route in one go, but that is obviously inconvenient, so we'd like the person to be able to pause it and come back to it later. In terms of the navigation Invisible Map, we were looking to add verbal feedback, so similar to Clew, just like turn left, turn right, etc. Also voice notes we think would be useful. So in Invisible Map Creator, for example, as the person's walking around, they can record notes that are like, to the left is the bathroom, to the right are the stairs, and things like that. We also want to integrate what Ben just talked about with floor detection to hopefully better infer paths that were not directly walked. And also potentially obstacle detection, so the ability to route you around something that suddenly appears that was not there when the map was created. And then the big thing that we would like is more user feedback. So we unfortunately just finished the 2 apps right before the end of the summer, so we weren't able to do too much user testing yet. We did get them deployed on TestFlight and had a few people test them out, and also hosted some office hours to talk about it, which we got some very useful feedback and really good ideas from, but we definitely want to continue with that and get much more feedback with the TestFlight apps and with our development as well.
So thank you so much. If you have any questions, you can drop them in the chat or speak up. And also, if you have questions afterwards, you can email us at the emails on screen, and we will also put those in the chat. Some questions in the chat were.
Oh, that's from before, yeah.
Oh, yep.
Yeah, and any questions for the Invisible Map team, or we could also open it to more general questions as well. But maybe if you have a question on Invisible Map first, specifically, we'd love to hear it. All right, how about any general questions for any of the presenters?
For the Invisible Maps team, the map process currently requires, these tags to be placed in a building as their markers, which requires, initial setup in a building. Has there been any thought to using anchor points that are, common objects that are in most rooms that are fixed instead of having to sort of pre-populate the room? Is that a potential future direction?
There is something that ARKit has, that Clew actually has implemented where, based on visual information, it can try to figure out if you're in the same location and where you are. So we did consider that, but we found that it's not super accurate. Like Clew oftentimes will not pick up that you're in the location and just has to trust that you have anchored at the correct spot. So there's definitely more work that could be looked into for that, but for now we think that April tags or similar methods are really the most feasible.
Yeah, like I feel like maybe the technology will get there, and I think especially if everybody had LiDAR on like a phone or like a headset or something, that would potentially make that a lot more feasible. But I just think the technology's just not quite there yet to be able to do that accurately enough. So this is sort of like I think a good thing where this is the approach I think that will work with the current technology that will be available over the next few years.
Yep.
Yeah.
Paul, this is Bruce Howell from the Carroll Center. May I just comment a little bit about today's presentation?
Yes, please, Bruce. Thank you.
Let me just say, I am so impressed at the depth of knowledge that your students and you have brought to this project, the time you've put into it, the incorporation of people from all over the world, including many who are blind or visually impaired. We do a lot of support for researchers across New England area here from many of the prestigious colleges and universities. And I have to say, you guys have really put phenomenal effort into this endeavor. You brought people with multidiscipline talents into it. Your students always impress me. I've done some things with Olin College in the past, and I just am always blown away at the passion, dedication, research effort that all of you put into this work. You explain things very clearly when you do the presentations. This is some really technical stuff beyond my technical knowledge, that's for sure, but I still felt really well informed by going through this whole process today. And the fact that you're just coordinating so many different aspects and disciplines of this rather complex but amazing mobile app that you guys are creating, it's very impressive. And I encourage all of you to continue to pursue career paths that build accessibility into things that you're doing. It's so important that people who are blind or visually impaired have the ability to navigate safely, to be able to do it as similarly to people without disabilities are able to do as possible. And we know that those present huge challenges at time, both from technology as well as the range of abilities that the different users have to be able to understand and use the devices and software that you're creating. But kudos to all of you. I think you're doing wonderful work. I hope there will be more opportunity to incorporate user testers into this to fine tune what you've done and give you some further data input to tweak things that you've created to make this a really usable possibility for many people.
Thank you. Thank you, Bruce. Yeah, I wanted to also thank you, Bruce, for your longtime collaboration with my team and me, and all the great work that you all do at the Carroll Center, and your work with digital accessibility auditing and consulting. You also do some great stuff there, so I really appreciate it.
Thank you.
The sentiments and also the work that you do in your collaboration over, I want to say at least probably 5 years now, probably something like that. Yeah.
Yeah, it's been a while. I know I've spoken some of your classes, you and Caitlin there at Olin College, but you've also brought students to our campus in Newton. We're not very far away from Olin College, so it's been a wonderful collaborative effort. And regardless of that, even outside of my work duties, I'm just so impressed at what Olin College is doing. The fact that you incorporate awareness of disabilities into so many of the studies that your students pursue there, it's very humbling, and we're very appreciative of Olin College for taking those steps.
Cool. Thanks, Bruce. Any other questions or comments on the presentations today, or even just generally about the sort of whole area of in mobility and assistive technology? Anything anybody has on their mind?
Hi, it's Hanif again from South Africa. I just feel the safety issue of people when they use assistive technology is very critical. Also, obviously integrating and using it in conjunction with other devices, your white canes, guide dogs, those kind of things, having to interact with ticketing machines if you go through, to the train or whatever the case is, having to be able to have as few additional items in your hand that you need to manage. That's really important. So what I'm saying, I've looked at the app itself. I know the app, but I don't use it because it's practically not workable for me. So yeah, that's all I wanted to say from my side. Also, obviously good work. It's exciting. I think we live in exciting times with all the different kinds of technologies coming out, and different opinions, and huge leap in technology, especially from the mainstream side of things. And that's it. Hanif from South Africa signing off. Thank you.
Well, thank you for that perspective, and I totally agree with you and the need to consider those issues more. And thank you for bringing that up to our attention again.
Paul, this is Bruce Howell again. So one of the things, maybe you assign some of your great student researchers there to design a better harness, if you will, or something that would allow the person to mount the phone in a way that would be more secure. Such things do exist, so you may not even have to start from scratch, but sounds like from some of the comments I heard earlier today, including the one that we just heard, keeping the hands free is such a valuable thing for all the reasons that he just stated. And there are others as well, just for safety, hanging onto a stair railing or something when you're climbing or descending stairs. So I think mounting the phones in some way that's more secure is probably something worth investigating.
Yeah, I think for sure. That's definitely something that I've been talking actually to some of my colleagues about pursuing a project along those lines, because it seems like right now there's like kind of two approaches. There's the very expensive like special purpose headset, or there's the wait for Apple to design like the technology that we're all going to use, or there's buy the $9.99 like lanyard thing, which is fine, but it's not really designed. It's not the perfect solution. So I think you're right that probably there's room for something that's kind of in between those two approaches, that's designed much more intentionally. I don't know if Kars is still on the call, but I know his team had been working on something like that, but I think that's a really good instinct that you're bringing up, Bruce, to think about that as a thing to work on from a kind of hardware standpoint. All right, well, yeah, just I guess want to say thank you to everybody for attending, and thank you to all the collaborators, co-designers for their input over the summer. give the research team here a round of applause for the presentations. So good job, folks. Yeah, thank you. So get in touch with us, clueapp@gmail.com. We'll be sending out slides and also recording later today. Okay, thank you, everybody.